In this video, we are going to start component 3, looking at the line of best fit and the correlation coefficient. So to get us kind of thinking in the realm of scatter plots, we're going to be looking at this table here. It represents data from the Monopoly game. So we have the different property names, the spaces that that property is from Go, and then the cost of the property. We're going to use spaces from Go as our X variable, and the cost of the property will be our Y. So looking at my scatter plot here, going across, this is representing spaces from Go. Up and down, we have the cost of the property. Now, A says to use the table and scatter plot provided to label the title of the scatter plot, the x-axis and the y-axis. I've already labeled the x and y-axis just by analyzing that table. The only other thing I need to do is make sure I have a name. So I'm going to name this Monopoly Spaces, and maybe I'll just leave it as that, Monopoly Spaces, and I guess I could add something in there about the cost. We're not going to be too picky about the title as long as you have one. Okay, part B says, is there a correlation between spaces from Go and the cost of the property? What prediction would you make concerning whether the correlation is positive or negative, strong or weak, and then we want to explain. Now, some of these words should sound familiar. Positive and negative we have talked about. Looking at my scatter plot, it looks like generally the scatter plot is moving upwards, so I would say that this has a positive correlation. Okay, I'm going to write that sentence for positive correlation. We've said that positive means as that x increases, so I'm going to say as the spaces from Go increase. Remember, we always say that that x value is increasing. So as the spaces from Go increase, now I'll talk about my y variable, which is my cost. What's happening to my y? Well, if it's positive, it's also increasing. So I will say that the cost of property increases. In this section, we are going to look at a new idea, which is looking at the strength. So when we're talking about strength, we're going to look at whether these things are strong or weak. If a scatter plot is strong, it means that the dots are very close together. They're going to be very close to that line of best fit. So I'm going to add a little note here. Strong means dots close to line of best fit. If a scatter plot is not strong, then we will say that it is weak. If a scatter plot is weak, it means that the dots are far from line of best fit. So strong will be close to that line, weak will be far. Now looking at my scatter plot here, my guess is that my line of best fit is going to be kind of somewhere maybe here-ish, relatively close to most of those dots. I do have kind of one outlier up here. This cost is like way, way higher than I expected. I would kind of expect that dot to be down here somewhere. So it's really hard to determine how strong or weak a scatter plot is without the line of best fit. So to get a better answer about that strength, we are going to learn how to find the line of best fit using our calculator. As we go through this example on page 25 and 26, I'm going to show you all of the steps using my calculator here, but you will also see little pictures of what your calculator screen should look like. Any words that we see in bold, which I am also going to highlight, any of these bolded words means that it is a button on your calculator. So step one, the first thing that we need to do when we're finding this line of best fit is to put the data into our calculator. So what I'm going to do is press Stat. Now Stat on my calculator is right here. It's underneath Delete, kind of right by those arrows. Once I press Stat, I'm going to hit Enter for Edit. Now, if you have some random stuff typed in there like I do, the best way to clear the data is to scroll all the way up. So I'm going to use this arrow here until L2 is highlighted. I'm going to press Clear and Enter. That's a really easy way to clear out that data instead of just going and clicking Delete, Delete, Delete. It's easier to go all the way up, press Clear and Enter. Now what I want to do is type this data that I have for my Monopoly example into my calculator. I'm going to put all of the spaces from Go into my L1, that will stand for my X's, and then I'll put all of my costs into L2, that will stand for my Y's. So I'm going to start with my X's. I'm just typing in that number, pressing Enter to move it down. Once I have all my X's, I'm going to scroll to the right and type in all of my cost for Y. Right, if you don't have all of that data typed in yet, now would be a great time to pause your video to finish typing in all of those X's and Y's. Alright, once I have all that data typed into my L1 and L2, I'm done with step one. I'm going to move on to page 25 so we can see step two. Okay, step two, to get that line of best fit, we are going to press Stat again. So that was right by my arrows. So I'm pressing Stat again. Once I have pressed Stat, I'm now going to arrow over to Calculate. So I'm going to hit this right-hand arrow. I'm done editing, so I don't need to click Edit again. Now I'm ready to actually calculate something. So I'm going to go to this Calculate. And this now gives me a list of all the different things my calculator can do. Right now, we want it to make a linear line, just a nice straight line. So I'm going to go down to number 4, where it says LinReg. LinReg stands for a linear regression. Linear meaning a straight line. Once I have number 4 highlighted, I can press Enter. Here I'm going to make sure that I have L1 and L2 listed because that's where I had my X's and my Y's. Most of your calculators should already have this. If they do not, so let's say you had something random here like a Q. Well, if I wanted to change that into L1, what I would have to do is press second, it's the blue button, and then number 1, and it should pull up L1. If you need L2, so let's say I had a Q there instead, I would press second and then 2, and it will give me L2. Alright, now what we're going to do is use this equation to help us predict answers. To be the most precise, we're going to store, which is really just a fancy way of copying and pasting our equation into Y1 so we can see our table. So what I want us to do is make sure that your cursor is blinking next to the store equation. So that's this 4th option down on your calculator. From there, we're going to press alpha, which is the green button on your calculator, trace, which is up here next to graph. A little box here should pop up. I want Y1, so I'm going to press enter, and then it gives me that Y1. Once I am done with that, I'm going to scroll down to calculate, which we don't really have on here, so I would maybe write down that we're going to calculate. I'll press enter, and your calculator will give you your slope-intercept form. Now, for some reason, they do change the M into an A. Just remember that slope is always what's next to that X. So my slope in this case is 6.71, and my y-intercept is that 70.197, so we're going to round to 2. Now, when I'm looking here, my calculator just gave me A and B. Eventually, we do want it to look like this picture here, where they have an R squared and an R. If that is not showing up, we need you to turn on your stat diagnostics. We should only have to do this once, so here's what we're going to do. I'm going to press mode on my calculator, which mode is up top here right next to the second. I'm then going to scroll all the way down until I see stat diagnostics. On my calculator, it's way towards the bottom. I see stat diagnostics. I want to arrow on to the word on, and I'm going to hit enter so that on is highlighted in black. Okay, from here, now when I run that linear regression, it should give me the R and the R squared. So let's practice that again. To get that line of best fit, we hit stat, we went over to calculate, and then I'm going to go down to number 4 where it says linear regression. I'm storing my equation by hitting alpha, trace, and then enter for Y1, and then I'm going down to calculate. I'm going to write my equation for my line right here in this y equals. So my slope is 6.71. So I'm going to write that as 6.71x. Notice that I am rounding to the nearest hundredth, so that's 2 after my decimal. My b value was 70.197, so that 7 is rounding the 9 up, which really rounds the 1 up to a 0.2. As a nice little recap of our last lesson, let's go ahead and interpret or talk about what the slope and y-intercepts mean in this problem. So the slope of the line of best fit is 6.71. I know that it's 6.71 because that's the number that has the x. In the context of this problem, this means that as the x, this is where I'm going to input my x variable. If you've forgotten what our x and y variables are, we can take a look back at page 25. I was using spaces from go as my x, cost of property as my y. So I'm going to say as the spaces from go, it's my x variable, increase by 1, and I want to make sure I have units here. It looks like we're measuring this in number of spaces, so I'm just going to say increase by 1 space. The y variable, so here's where I can put my y, which was the cost of the property, now I need to think about whether this is increasing or decreasing. Because my slope is positive, I can say that this is increasing. So I'm going to say increases by, here's where I will put my slope number, which was 6.71. And we're measuring cost, so I'm assuming that this is in dollars. I remember every time we're using that slope interpretation, we can use our little template. I'm going to give you that template again off to the side here. It says as the x, here's where you input your x, increases by 1, the y increases or decreases, could be either one, just depending if your slope is positive or negative, by, and then in this one we'll put the actual number for our slope. We can use that template every single time that we're talking about the slope. Okay, next up I have the y-intercept. The y-intercept should be the number in my equation that does not have an x. So that would be 70.2. Remember that my template for the y-intercept talks about the ordered pair. So it says that when x is 0, so when your x is 0, the y is whatever number we're using for our y-intercept. So in this problem, I would say when, here's what I'll put in my x again. So when the spaces from go is 0. I'm going to say 0 spaces. It's a really weird way of saying I'm at go. I'm not even one space away from go when I'm at 0. The cost of the property, that's my y, is, and here's where I'll put in that number value, 70.2, and I'm measuring this cost again, so this is dollars.